Welcome back. This is an Aleks homework video on using the Van 't Hoff equation to predict K at a different temperature. All right, scary because it's a big ugly equation, but really you're just filling in what you know. And really, in order to use the Van 't Hoff, I have to know the heat of reaction. So some of these questions are going to supply you with the heat of reaction and some are not. If you don't have the heat of reaction, it's easy. You just say, no, I can't calculate the K sub C at the new temperature. If you do, then you're just going to put in the heat of reaction and fill it in at the new temperature. It's not really that hard. It's just, it looks very intimidating, at least to me. Okay, so a couple things to keep in mind. If you have a negative heat of reaction, then you have an exothermic reaction. You're releasing heat. Okay, so the reactants is producing products, but also producing heat. So heat's thought of as one of the products in an exothermic. If, as the temperature raises, okay, so if you go from one temperature to another and it gets higher, then if you have an exothermic reaction, your K sub C should go down. That's something you would look for. And then it's converse. If the temperature drops, then your K sub C is going up. If you have an endothermic reaction, okay, so you have a positive heat of reaction, so your delta H is positive, then as the temperature goes up, your K sub C will also go up. So those are directly related. So that's one thing to keep in mind. In this example that I have an exothermic reaction. Temperature has dropped and I have a negative delta H. So I should expect my new constant to be higher, even much higher. And we'll look and see. All right, so just to remind yourself, if you are the lucky one, you won't even have to do much of this problem if you do not have a heat reaction. So you could try to keep renewing until you don't have a heat of reaction. That'd be awesome. Otherwise, you simply have to use the Van 't Hoff, which looks ugly, but it's not that bad. Okay, so if you do know your heat of reaction, use Van 't Hoff. If you don't, then you're just going to say no, I don't, and then you're going to say no also to number 3 because if you don't know the heat of reaction, you can't fill in the Van 't Hoff at all, and you can't even guess whether your K is going to go up or down. Now, if they give you one to where you have the heat of reaction but don't have the temperature change, then I don't know how you could answer question number 3 if you don't answer question number 1. I don't know. I've done several of these, but I haven't gotten to that kind of question. But that would be the easier of these possibilities. So you're just going to use the Van 't Hoff. All right. So a couple things to keep in mind. The heat of reaction in my example was given in kilojoules per mole. But in order to do all these cancelings, you're going to have to change it into joules per mole. So that's one thing to keep in mind. Also, you have 2 gas constants. Remember, you have a liters atmospheres over Kelvin moles, which is whatever, 0.08 something. You can't use that one because we don't have liters and we don't have atmospheres here. So you're going to have to use the other one, the 8.31457, I think, or something, joules over moles Kelvin. You're going to have to use that one. And then remember, your temperatures have to be put in kelvins. So if you remember, we're looking at, go back, I wrote down just a few things. So I first of all wrote down 7.8 times 10 to the 4th joules per mole, and I wrote down my new temperatures in Kelvin just so that I would remember that. Okay, so fill it in. So I've got my original K sub C, my K1 is 8.4 they gave me. It has to be a negative delta H because it's exothermic. It's losing heat, so it has to be negative. If it was gaining heat, it'd be endothermic and it'd be a positive number. That'll mess you up if you don't do the negative properly. Remember, the entire thing is negative, and then I'm going to use 8.3 as my gas constant, and then put my 2 in. You remember it's 1 over T2, so the 244 is my second temperature, though 257 was my initial. All right, so I simply just did the algebra, ugly, and I got the natural log of K2 over 8.4 equals 1.98. So if I'm going to get rid of the negative log, then I'm going to have to take the e to the x. So the 1.984 is the x in e to the x. You have an e to the x button on your calculator. So the K2 over 8.4 is e to the 1.98, etc. Gives you 7.2. And then I just brought up the 8.4, and I found that my K2, they asked for one significant digit here, no, two significant digits, was 6.1 times 10 to the 1. All right, so what do we write? Well, the first one is, can we use the facts? Yeah, we can use the facts. What was my answer? It was 6.1 times 10 to the 1. And the third question says if I said no, and I said yes. So in this case, that's all I got. So I hope this helps you.